Alright guys, so in this video we are going to continue our focus on using U substitution as a way to evaluate integrals. But our goal for this video in part 6 is to really dive into taking evaluations of integrals in which we have to use a trigonometric identity. Alright, so let's kind of start some things on off with and dive into one right here real quick. Let me erase this one that I have on the board to start some things on off with. Not this one here. Alright, so the first one that we're going to look into for our purposes for today is going to be the integral of dx over cosine squared and then of 2x. Alright? And so where are we going to begin here? And so obviously our goal as U substitution is to be able to somehow, some way, get this into a favor that makes more sense for us. Okay? But sometimes substitution might not be necessary. Sometimes it might just be a manipulation to rearrange what we know about trig identities or anything of the nature. And so let's look into this real quick. I mean, we see what's happening right here. This, remember, has the same thing as 1 over cosine squared of 2x, right? Times dx. Same thing is happening in both those two scenarios that we're dealing with, right? So think to yourself for a sec. What does 1 over cosine squared 2x be? Hopefully, you have the idea that, well, 1 over cosine is just secant, right? So 1 over cosine squared would be the secant squared. So this is all still equal to secant squared of 2x dx. Now we're getting somewhere. Because now we're going to start being able to make some changes to things that are happening in here itself. So what do you guys think? What do you think is going to be a good possibility as a U substitution to go ahead here? Hopefully we're getting pretty comfortable with some of these and understanding that probably 2x is our best bet. 2x is probably going to be our best bet to be our U substitution. So let's let U equal 2x, which means du will equal 2 times dx. And I apologize for the very boxy writing that's happening here. I have no idea what's been happening with OneNote lately. But kind of moving on forward, so this is 2dx. 2dx. Alright. So now, let's kind of think through stuff. So du is 2 times dx. That means I have to have 2 times dx somewhere in this original. And so, well, what if we went ahead and rewrote this as 1 over 2 times the integral of secant squared of 2x times 2 dx. Now we're in business, because now we have 2 times dx and 2 times dx in both scenarios. And now I can make the full substitution and say this is 1/2 times the integral of secant squared of u times du. And now we're in business, because the antiderivative of secant squared is just tangent, and that makes our life nice and easy. So this is 1/2 of tangent u plus c. Well, in this case, that is 1/2 times the tangent of 2x plus c. Alright, so a little interesting one there. So I got one for you I want you guys to give a shot on your own. Alright. Your practice for this is going to be evaluate the integral of cotangent squared of 3x dx And then the answer to this one, when it's all said and done, you should see that it is negative 1 over 3 times the cotangent of 3x minus x plus c. Now, before you get rocking on this, all right, I want you to really analyze the answer here first, okay? As you're getting warmed up into these trig identity type evaluations, all right? Warm up to the answers. I've given you the results when this is all said and done. As a way to kind of get comfortable, look at the answer. You have cotangent 3x being one of the terms, and you have a negative x in there as well too. Use that noggin to think about what had to have been the step before cotangent. What had to be the step before negative x, right? So think about that, what's happening in these particular examples to get to this end result that we have. Give it a shot, see how it goes, and we're on to the next one, folks.